Okay, so today is called 4.7, number 1, and it is about, listen please, it is about inverse functions. The most common mistake people make when they look at this is they think, oh, that's the little thing that's on the calculator above the sign, and they think, oh, inverse, that means like cosecant. Okay, well, there's inverse, and then there's reciprocal. They're two words that a lot of times get mistaken for each other, and I want to make sure you get the difference. This inverse sine of, for instance, square root of 3 over 2, here's a typical question. That right there is a question that's just written in a way that you're not used to. And it is not asking about, I think people think, oh, so that means you flip it, and that means that it must just be cosecant problem. It is not. It is not related at all to that. Okay, what it is a rewrite of this problem, and I'll show you why. It is a rewrite of sine of some angle is equal to root 3 over 2. Do you get how this thing is not an angle? That thing right there, that's not an angle. Those are sides. You know, normally you write things like this, sine of an angle, like 30 degrees, and then you want the sides over there. In this case, they've got the sides right here where the angle usually is, and then they have this little inverse thing. Okay, so here's what it means. If you can take something like this and just realize, did they give you a set of sides or did they give you an angle? Then you're going to be golden on these and it'll be easy. So, did they give you an angle or did they give you sides? They gave you sides. So then if you rewrite it like this, the problem instantly becomes really easy. It doesn't have one of those little negative ones in it anymore. Okay, so now it's just sine of something is root 3 over 2. And then you got to ask yourself, okay, so what do they want? They want an angle. So how am I going to figure out the angle? I guess I better draw a triangle. So I draw a triangle. Everybody draw the triangle for this thing. Put it in the right spot too, because there's 4 places you could put it and only one of them's right. Okay, well, would you agree that sine is positive actually in 2 places? All students take calc. A lot of you probably started right here, and that's okay. It's a correct answer to put one there because sine is positive there. Sine is opposite over hypotenuse. Opposite is root 3. Hypotenuse is 2. There we go. And do you get that this side must be 1 then? And so, which angle is sitting right here then? Is that the 30 or is that the 60? That's the 60. So the answer to this thing is 60 degrees. Could you also say that the answer was pi over 3? It's the same thing as 60, right? Yeah, you can do that. All right. Let's address the fact that over here, if I were to do this one over here, sine of this angle is root 3 over 2. Sine is opposite over hypotenuse, so from coming from this thing's perspective, opposite is root 3 here, and the 2 would be there, and this would be a negative 1. Okay. And what other angle would also give you root 3 over 2? That one. And if this is the 60, then that must be the 120. And if that's 120 degrees, then in radians, you should be getting decent at this now. 2 60s, and each 60 is pi over 3, so 2 pi over 3s. All right. So, and this one was just a 1 pi over 3. Okay, so let me just ask you a few more questions that are like this and see if you start catching on. Would you agree that sine of 30 degrees is equal to a half? Have you got that one memorized yet? Sine of 30 equals a half. All right. Then that would mean sine of 1/2. Inverse sine of 1/2. Would you rewrite that as a more normal problem that doesn't have a little negative 1 in it? And you'll see the question's pretty simple. Rewrite this without the inverse part. Write it as something, something, something with an equals in it. All right, you should have written sine of some angle is equal to 1/2. So if you get stuck on these, always ask yourself, did they give me sides or did they give me an angle? And they gave you sides in this case. 1/2 isn't an angle. And if they gave me sides, then the sides are supposed to normally go on this side of the equation, and the angle is supposed to be right there. So it's basically saying sine of what gives you a 1/2, and what's the answer? 30. Is there another possible answer? Would sine of 150 also be a 1/2? It would. All right. And just be careful if they want radians or degrees. Okay. All right. I hope you're starting to catch on to this. How about the inverse tangent of 1? I ask you again, did they give you sides or did they give you an angle? They gave you sides. Rewrite this as a normal tangent question then. Tangent of some angle is equal to 1, and I would put 1 over 1 personally. You get how they're really asking you an angle by doing this? Okay. Now, tangent, where's tangent? Tangent is opposite over adjacent. What kind of a triangle would you be in if your opposite side and your adjacent side, which would be like this one and this one, were both 1? 45. Also known as pi over 4. Good. Okay, I think you're catching on. How about this? What if tangent was 0? So I go tan, inverse tan of 0. Try that one. Without any help from me. Just figure it out. Yes, you can say 0 over 1. 0 over 1 would still be 0, wouldn't it? Hard to make a triangle with a side of 0, isn't it? So it must be at one of those places where you can't make triangles, right? Which means it has to be on one of the, what are called quadrantals. 90, 180, 270, or 0, which is 2 pi. So what I wanted you to do first was write tan of some angle is equal to 0 over 1. How many you got that far? Raise your hand if you did. Okay, good. Then you should know what we're talking about here is an impossible triangle. Therefore, it must be at one of these spots. Here, or maybe it's here, or maybe it's here. Places you couldn't draw a triangle. So then, which one would work? What is tangent again? What over what? Y over x. And some of you messed that up yesterday on the test. So what do I want? I want y to be 0 and x can be 1. Could x be 0? No, because then it'd be 0 over 0, and that's undefined, and that's not 0. Okay, so basically I want the spot where y is 0 and x is 1. Where is that? Is this spot 1, 0? Is that a spot where x is 1 and y is 0? Is there any other spots like that? Let's just check this one, -1, 0. Is that a spot where y is 0? Now, does x have to be negative, or could x be -1 and wouldn't it still make a 0? So there's actually 2 places, this one and this one. And on yesterday's test, a lot of people messed this up. A lot of people said, oh, so it's pi for this one. And then, okay, I just realized there's some people in here who haven't taken the test yet. So I'm not going to finish that thought. All right, anyway, let's move on. The next one, it looks different, but it's the same. Oh, wait, you know what? I want to set up one more thing that I think is interesting for you. I want to show you where this came from. If you had this, sine of theta equals 1/2, do you agree now that these both mean the same thing? You can transfer the one into the other, and you're just rewriting the same problem. Still isn't answered yet. It just helps you to see it, okay? Well, here's where it comes from. If you started, I'm going to put this off to the side here. If you started with this red one here, and you said, you know how you want to solve in math a lot? You usually want to solve for a variable, get the variable alone. What's the variable in this? Theta. This theta right here. How can I get it alone? If I could only get rid of sine somehow. Guess what gets rid of sine? Inverse sine. if I do inverse sine of this side, and I do it to that side of the equation, do you get I'll have to do it to the other side of the equation? So I'm going to take this 1/2 and I'm going to just move it over there. And now I'm going to do inverse sine on both sides in black. And what happens to inverse sine and sine when they touch each other? Pew, gone. Look what I have. Same thing that I started with, see? So that's where these problems come from, is they're trying to take theta and get it alone if you have a problem like this. Let's go with cosine of some angle is equal to √3/2. If you wanted to get the theta alone, and you did this, that would cancel that, and theta's alone, and then the problem becomes inverse cosine of √3/2. So that's why your test question would look like inverse cosine of √3/2. It's not that crazy of a thing. It's just solved for theta. My first step on all of them, though, personally, would be to rewrite them and make them like the black one. And say cosine of some angle is equal to √3/2. Just because you'll be messed up less often if you start with something you're more familiar with. And you'll see, oh, so I need an angle. And then you go, okay, which angle must it be? Well, it's probably, with a √3 and a 2 in it, do you agree it's probably the 30, 60, 90 triangle? So then it's either got to be the 30 or the 60. It's definitely not going to be the 90. So then you have to draw your triangle and figure it out. So it's not that hard once you just rewrite the problem. So if you're good at rewriting them, you're almost done. There's only one other thing that you got to understand, and that's that you can write a problem like this, or you could write the same exact problem like this. Arc cosine. Arc cosine is the exact same thing as inverse cosine. This red one and the black one are identical. So if they start asking you arc cosine, same thing, I would rewrite the problem just as if they had given you the black one, the inverse cosine. They're the same question. It's just a different way to write it. I have heard different theories from people about why the arc thing came into effect. Like, why did people start doing this arc thing? One, and I had heard this one, and another teacher verified that they had heard this too, that this had to do with back in the day when there were typewriters, okay, before there was computers. I know that seems like to you forever ago, but when I was going to high school, the first computers had just been built. So it was like right before I went to high school. And that's a lot of time between then and like the founding of the country. There were typewriters. And the typewriters, it's really hard to get raised up things like this. It was hard to get like an exponent or anything in there. And so they could type this without having any exponent, see? So arc cosine means the same exact thing as cosine with a little -1. Okay, same exact problem. So then how would I start if I had been given this? I would not rewrite it as cos -1. I wouldn't say inverse cosine. I would say, okay, so that's this one. Cosine of some angle is equal to 1/2. And now I got my sides over there where they're supposed to be, and I can see that I'm looking for an angle, and then I can go, okay, it's a 1 and a 2. It could be, let me think. Oh, it's got to be the 30, 60, 90 because the other one's 1, 1, and √2. So yeah, this must be the 30, 60, 90 triangle, and then I draw it and figure out which angle it is. Goodness? All right, I think you are. So let's hand out the worksheet, do a couple with you. I'll pause for a second, I'll hand those out. Okay, now that you got the worksheets, do you all have the worksheets? Okay, good. Then let's do the first couple of problems. Number 1, I think I already did with you. I'm sure you can handle that later. Number 2, let's do that one. So number 2 says sine with a little -1. I want you to know how to say it. It's called inverse sine of 1/2. My first thing for me, rewrite. I'm rewriting it. Question? Have we done number 2? Yeah. Okay, thank you. Let's go on to number 4. Sorry, number 4. Let's do cos with the -1, also known as inverse cosine of 1. I would rewrite it right away. I'll do it in black. As cosine of some angle is equal to 1/1. Always make it 2 sides. It makes it so much easier. Now, where am I if my cosine is adjacent over hypotenuse? How can I have my hypotenuse and my adjacent be the same exact size? Is that a normal triangle? No, you can't do that. So therefore, it must be one of these places. And then you got to figure out, where am I? There, 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 or there. So what is cosine again? Is cosine y? Cosine is x. Yeah, that's right. And since cosine is x, we are going to go 1, 0, 0, 1. Where is cosine 1? Or where is x 1? So this is 0, no, this is -1, 0, and this is 0, -1. Where is the x 1? That's a spot where x is 1. Is there any other spot where x is 1? No, that's got to be it then. And if your directions in the problem had said that you need to stay between 0 and 2 pi, not including 2 pi, then you couldn't give the answer of 2 pi, could you? So therefore, we shouldn't say 2 pi, we should say 0. Or if you want to say it in radians, it would be 0. Okay, fine, 0. Okay, on to number 5. I skipped number 3, just put the 0 over 1, and I did one like number 3 on the board before. Let's do number 5. Arc cosine of 1/2. Personally, instead of arc cos of 1/2, I would put cosine of some angle is equal to 1/2, because it'll make more sense to me. And I'll say, oh, so you want an angle. And now I'll make a picture, and I'll figure out where I would have an angle that would give me, or where I'd have a triangle that would give me this situation. Triangle where cosine is adjacent over hypotenuse. The adjacent side is 1, the hypotenuse side is 2, and this must be square root of 3, and that makes this a 30, and that makes this a 60, and therefore the answer is what? Not 60, because the directions, if you read them, it says radians. What's the 60 the same as? 5 over 3. And circle it or something. A lot of people, when I was grading your test, didn't. You had like 6 or 7 different. Wait. Oh, I know, but give me a second. A lot of people on their tests had like a whole bunch of numbers, and they didn't like identify which is the answer. You have like 9 numbers in your paper. Which one's the answer? I'm not just going to pick the right one for you. A lot of people did that. Yes, but I'm not. I can't do that. Okay. Now, I am questioning myself on whether or not we need to give 2 answers. It does not say in the directions that we need to give all answers, or that we need to give. So I'm just going to give. I'm okay with you just giving 1 answer. I won't make you go find the other answer, because I don't think, due to the directions, that we would have to have any more than 1 answer. And I might have something going on like wrong in my head that even allows 2 answers. So just go with 1. I know the 1 answer will be right. And I'll talk to you more about that tomorrow as I process what I'm thinking about there. All right, I'll start number 6 with you. Yes. First of all, would you agree that we got to rewrite it from inverse tan? So therefore, instead of inverse tan of 1, tell me what you think I should rewrite that as. Tangent of theta is equal to 1 over 1. Okay. Now I got to try to figure out where could I draw a triangle where the opposite and the adjacent are 1? Yes. And there is a triangle with the 1, 1, and the other side square root of 2, remember? I think you'll figure it out from there. It'll be easy. All right, if I do any more of these, you won't have any homework to do. So anyway, get to work. If you need help, ask. And I will be working on grading your tests up here.